This typical delta gradually progresses in the downstream direction A close look at the top-set slope in slow motion clearly shows a laminated deposit of finer particles. The thickness of the top-set deposit decreases in the downstream direction as the foreset slope of the delta is approached.
Over a long period of time, the accumulation of sediment displays clear stratification, with fine particles on top, coarse particles in the middle, and fine particles on the bottom. It is important to understand that the chronology of the formation of the deposits depends on the layers and not on the strata.
Isochrones correspond to the interface between successive layers, not strata. The thickness of strata is determined by the changes in sediment transport that occur in non-uniform flow.
Let's now consider two particles in the delta. Particle A in the upper strata and particle B in the lower strata. Particle A deposited at a time T1 before particle B. Particle B in the lower strata therefore deposited after particle A in the upper strata.
Increasing the flow depth while keeping the discharge and the supply of sediment unchanged results in more complex sedimentary features. Substantial deposits accumulate with features including deltas, dunes, and ripples at various stages of development. A dried delta, viewed from the flume sidewalls, displays clear stratification characteristics in terms of superposition of deposits with similar particle size distribution. A cross-section is cut through the delta to examine the primary features of deposits of sediment mixtures carried out under steady flow and a continuous sediment supply. The cross-section displays a clear superposition of strata of fine particles in white and coarse particles in black with clear lamination. Looking at the cross-section of superposed strata, it is tempting to conclude that the strata correspond to successive sedimentary layers, that they result from discontinuous sedimentary periods, that each strata is younger than the one underneath it and older than the one above it, and that all points of the same strata have the same age.
The stratification experiment invalidates these hypotheses because these strata are not identical to successive layers. Moreover, clear stratification is observed under a continuous supply of heterogeneous sand particles.
Looking through the transparent sides of a large tank or flume, he studied the particles of sediment in the moving water. He observed that when the speed of the current was reduced, only the large particles of sediment were deposited. When the current was increased, microstrata started to form. So the grading of particles in strata was not just the result of layers of sediment piling up on top of each other, as had always been thought. The grading could simply be due to variations in the speed of the current when the particles were deposited. When the sea level drops and the damp sediments are exposed to the air, breaks occur between some of the strata as part of the drying out process. So these joints or breaks have nothing to do with time. These experiments, performed by a team of experts over many months under the most rigorous laboratory conditions, have been filmed and are available for all to see. They confirm the most important fact ever discovered in the history of sedimentology. Strata provide no indication of age. Ghiberto has shown that the strata you see in these banks are caused by changes in water currents. They don't just deposit themselves one upon the other over vast periods of time. They form sideways in a crab-like fashion, just like the banks.